Given the car cruising at constant velocity with the free body diagram as shown, does the normal force do any work to the car? Well, the normal force is pointing upward. The car is displacing to the right, so it might make sense that the answer is no. No work is done by that since those are at right angles. Does the drag force do work to the car in the picture below? What kind of work does it do? Well, the drag force is pointing to the left here in the free body diagram for a rightward moving car. I think it represents the air drag that is being applied to like all the surfaces of the car, maybe also to the windshield, etc. And since it's in the opposite direction of displacement, I'd say yes, it does do work, but it's going to be negative work. So yes and negative are the answers I'd like to give there. There they are. Okay, one more question in this series. It says, what kind of work does the traction force do to the car? Positive, negative, or none at all? And based on the diagram, one might be inclined to say positive work because traction points in the same direction as the displacement of the car. But there's something subtle going on here. And to see what that is, let's look at like how a tire on a wheel might actually make contact with the road and like what's going on there. So I'm going to have sort of a flat section of this tire here. I'm going to try to complete it in a somewhat roundish fashion. Okay, that'll hopefully be good enough. And then maybe here's the road that the tire is kind of going over. So the road does not displace. That's pretty obvious. But the system we're interested in here is the car. So the fact that the road doesn't displace might not be the most telling thing. But the thing is as the wheel is turning and the tire is rolling over the road, the rubber where it meets the road is also not displacing. In other words, there's no displacement here at this point of contact. And so I want to argue that no displacement implies no work is being done, since you need to have displacement in order for work to be done. It turns out there's a deeper way of looking at this as well. Like in that sense, if I ask like, when you run out of gas, where do you put the fuel? In the car or in the road? That's a really silly question, right? Nobody puts fuel in the road, you know. Maybe there'll be some really futuristic though form of car where they can just get their energy right from the road they travel upon. But for right now, that's not our reality yet. And how does that relate to this question? Well, it turns out at a deep level, work actually represents a transfer of energy. And in that sense, if the road were doing work to the car, that would actually kind of be doing what normally the gasoline and the engine and all that kind of does for us. Really, in that sense, the fact that the car is able to, like, let's say it started at rest and it sped up and gained kinetic energy, you could say that that's an internal transformation of the chemical energy in the gasoline being converted into chemical energy through the way that the engine and all the other parts of the car work. But the road actually doesn't have to supply any of that energy at all. And that is perfectly in alignment with this answer of no work, which in terms of the three choices given to us here means none at all should be the correct answer. And there it is.